Hello everyone, today we're talking about our project named Desulfurization in crude oil to decrease PM2.5. I believe that you already know about PM2.5, right? Because PM2.5 is very big issue in Thailand and also many countries around the world. So the government in many countries try to find a better solution in this problem. And I think as a chemical engineering student, we know that the source of PM2.5 and the method that used to decrease PM2.5. So that's why this project has occurred. So first of all, I will introduce our member. My name is Parame Chodayanon.
My name is Silavik Kim.
My name is ณัฐพงษ์จงเจริญ
My name is พศธร มโหฬารวงศ์
My name is นรพัฒน์ นาคภักติ
Okay, let's talk about our project. So what is PM2.5? PM2.5 is particle matter has 2.5 micrometer. So if you look at the picture, you can see that PM2.5 is very small particle. If you compare with diameter of your hair, you can see that PM2.5 is very smaller than diameter of your hair, approximately 30 times. So I think this is not good idea if you have this particle in your body, right? Because PM2.5 can affect to many systems on your health. So this picture show effect of PM2.5. PM2.5 can affect to many systems such as the respiratory system, cardiovascular system, your eye, your lung, and your skin. So the question is, where do PM2.5 from? The pie chart show the source of PM2.5. So the major source of PM2.5 is urban burning, and the second is industry, and the third is transportation, and the last one is power plant. In this project, we focus the PM2.5 that come from transportation because we know that we can use the engineering knowledge to control it. So in this slide, I will talk with you about reaction of flow in your car. This picture shows combustion reaction. Combustion reaction will happen when you have three components together. And combustion reaction can make your car can dive on the road. So normally, if your fuel is purified fuel, the exhausted gas are carbon dioxide and water. But if your fuel is not purified fuel, your fuel is contaminated with sulfur compound. The exhausted gas is not only carbon dioxide and water, but it can generate PM2.5 also. So that's why the car or the transportation is one of source PM2.5.
Okay, next, I'm gonna talk about theory. So, what is desulfurization? To answer, the combine with three words. That is, D is mean remove, and sulfur is mean sulfur, that is element, and the last one is ionization, is mean mechanism of process. Hence, the summary, that is the process or mechanism that remove the sulfur. Then, the desulfurization has two main methods. That is desulfurization with hydrogen, that consists of hydrodesulfurization without catalyst and hydrodesulfurization with catalyst, for such as cobalt molybdenum or nickel molybdenum. And the second is desulfurization without hydrogen, or you can call this process oxidative desulfurization and solvent extractions. So I want to give you more detail from the previous slide. Start with desulfurization with hydrogen. Okay, the hydrodesulfurization without catalyst. So you can see this picture that have two reactions. The first is use hydrogen to remove the alkene. You can call this process hydrogenation reaction. And next is use hydrogen to remove the sulfur. You can call this process desulfurization. Okay, next is hydrodesulfurization with catalyst. That use hydrogen and catalyst, for such as cobalt molybdenum or nickel molybdenum, to remove the sulfur. That you can see the picture, the sulfur is removed. And next is desulfurization without hydrogen, or you can call this process oxidative desulfurization and solvent extraction. That divide in two steps. The first step is oxidative desulfurization, which the process that rearrange the sulfur group in the compound from sulfide form to sulfone or sulfoxide form by oxidizing agent and catalyst. And then the boiling point and polarity of the compound will increase so that it will be easy to remove the sulfur by solvent extractions. Okay, I want to give you more example about oxidizing agent, that is hydrogen peroxide or nitrogen oxide. And the example of catalyst is chromium trioxide or tungsten trioxide. Okay, and next is solvent extraction. That after oxidative desulfurizations, the sulfur compound is more polarity. Then the sulfur is separated by solvent that have the same polarity. And the method of solvent extraction that have two methods, that is extraction by acid or extraction by caustic treatment.
Now you have seen the theory of desulfurization. Let's see the process. The oxidative desulfurization or ODS process have two main operations. First is oxidize sulfide to sulfone, and second is remove sulfone out of liquid fuel. The figure is process flow diagram and show the full section of the ODS process. The first section is oxidation reactor. The fuel, oxidant, and the solvent are mixed in the steam and flow to the reactor. After enter the reactor, the sulfone are oxidized. The sulfide are oxidized to sulfone. After the reaction, the liquid are in the two phase. The two-phase liquid are flow to the separator. The sulfone are separated out of the liquid fuel. The sulfone feed are enter the third section, the solvent recovery, and enter the distillation column. The solvent are out of the top of column. The sulfone are out of the bottom of column. And the last section, the liquid fuel are enter the polishing section and enter the absorption tower. The remaining sulfone are absorbed in the tower and the feed are flow out as a clean fuel. The remaining sulfone are extract out of the bottom of distillation column and flow to the sulfone steam.
In this part, we are talking about an experiment. Oxidative desulfurization process is extract the sulfur by three solvents. First is ethanol, second is acetone, and third is acetic acid. When we designing an experiment, we will vary one variable and constant other variable to find the best value for the variable that we vary. As I say, for the first table, the variable that we vary is type of solvent and constant others such as pressure, temperature, ratio, or time to find which is the best type of solvent to remove sulfur. The result is acetic acid. It removes sulfur the most and left least of sulfur. And the second table is vary ratio acetic acid per diesel fuel. The best is 2 acetic acid per 1 diesel fuel for left least of sulfur. The third table is vary temperature. The best temperature is 70 degrees Celsius. And the last table is vary time for process. In this table, we are not only see at least sulfur, but the color of fuel is also important. So for not change color and left least of sulfur, the best time is 60 minutes.
In conclusion, if we look at the experiment data, we will get the condition that produce at least sulfur in diesel fuel. First, we must operate the reactor at 70 Celsius and time to make the reaction is 60 minutes. Next, we use acetic acid as the solvent in our process that called separation, which using product from reactor and acetic acid in ratio 2:1. And then if we take a look at each part of the process, first we feed diesel fuel and aqueous oxidant to reactor and make them react to each other about 60 minutes and control the temperature at 70 Celsius in order to produce this sulfur in our final product. Next, the product from the reactor will mix the solvent called acetic acid in the ratio of 2:1. In this process, acetic acid will pick out the component of sulfur called sulfone. After that, spent aqueous and catalyst then separate out from the bottom of the separator. Then separate sulfone from catalyst and spent aqueous. The next part is extraction. We extract the solvent which has sulfur from diesel fuel and we get clean diesel. Then we focus on number 4. Sulfur from the term of sulfone is removed to make more value. And then final, we will get clean diesel which has 5 ppm of sulfur.
So until now, I hope that the method that I want to talk with you will make you get more concept, will make you get more understanding about PM2.5 and the method that you dedicated. So that is our project, and thank you for your attention. Thank you.